Hi, I'm Tim Tickle. I'm here to talk to you a little bit about my final project for CSCIE90, where I used AWS Healthomics to perform processing and analysis of short read sequencing data. First, a little context about what short read sequencing data is. One technique for understanding when you're analyzing DNA, for instance, in samples, is to use sequencing technologies. So up on the left-hand corner, you would have samples and you would run them through a sequencer. And what you get out of that uh, often are these short sequences of DNA that was found in the sample. And so you have a whole bunch of these short sequences of DNA, and you have to be able to align them back to where they originally were. And so what you can do to do that analysis is get a reference genome for that species. So say for instance, we're using humans. We have a reference genome for humans, and we take those sequences and we line them back onto the reference genome. And so here we have these sequences, or what we call them reads. We read them from the genome. So these reads, and they've piled up along the reference genome. And so with that, you can learn all sorts of different information from the genome. One example is, for instance, mutations. In this example, at this location on the reference genome, there's an A nucleotide here. There's supposed to be an A there. But instead, in our sample, there was a whole bunch of C's. And so this is an example of where likely this is a mutation. And so you can do all sorts of analyses downstream with that. You can also use annotations to better understand the context of that mutation as well. For instance, here chromosome, we have the sections of the reference genome here sectioned off as different chromosomes. So we can tell, for instance, that this chromosome, this mutation's in the second chromosome. And as well, things like ClinVar, for instance, are databases of locations on the genome where mutations can occur, and if so, if they are potentially pathogenic, for instance. And so in this case here, this mutation's on this chromosome and is potentially pathogenic. And so that's a kind of analysis and processing and query that I will do on AWS Healthomics and Athena. Typically, what does this analysis look like without being on the cloud? Someone will have samples that will run through a sequencer, and they'll get FASTQ files, which are their sample files. They will also have reference genomes, which is a FASTA file. I'll show you what these files look like as we get to them. And then they'll use both of those as inputs in a workflow. That workflow will process the samples, and then you'll get VCF files or variant count files, which have different mutations inside of them. And I'll show you what that will look like as well. And then you can combine that with different annotations to do similar kinds of analysis that I showed, or other kinds of analyses. So what is that? So we're going to use Health Omics to do a lot of that workflow. And what does that look like in Health Omics? So your FASTQ files in your S3 bucket are going to be turned into sequence stores. Your FASTA file will be turned into a reference store, and those will be used as inputs to a workflow, which will give you an output VCF file that's stored back into an S3 bucket. From there, the VCF file is used to create a variant store of all the variants that you found. And the annotation, you can create annotation stores using things like ClinVar, for instance, as an example. And once again, ClinVar is a database, a VCF that has a whole bunch of different clinically applicable annotations about mutations. The annotations and variants can be combined together and queried together or separately in Athena, and I'll show you some of that. When you're thinking about health omics, this first piece here, creating the sequence stores and the reference stores, is the health omics storage. Health omics workflows is processing inputs and creating outputs, and then the analytics, health omics analytics is the variant stores, and that is also using AWS Lake and Athena all together to do queries. I'm going to be showing you most of the workflow that I went through before we get started. Just a couple things to be aware of. This project uses US East 1, so please be aware of that and maybe try to use that if you can. A lot of the resources are in that space. This will require an S3 bucket, so please do make one, and you'll put VCF files in there and also Athena queries in there as you're going, and then a custom trust policy needs to be created for this project as well. And these are the kinds of policies that need to be added to it. I'll go over that briefly. We'll come back to this in just a moment, but we're going to move over to demonstrations. First, we start off demonstrating being able to do the create the role. And so what we're going to do here is click role, create role. And I've already created this role, by the way, the Omics Unified Job role, but we're going to create role, create custom trust policy. In here, in my document, I give you the text to paste in here. And then after that, next. And then we'll add in different policies that I mentioned earlier in the slide deck, but to show you sort of what that looks like. For instance, doing this, and then after that, click, after you've added all of them, you click next, and then give it a name, a description, and then you'll finish it out by creating. We're not going to do that because it's already been created for us. We're going to now move over to the health omics. All right. In health omics, you have all sorts of things here on the left that we'll be working in. First thing we want to do is build a reference store, very top here. So we click build reference store. As you can see, I've already built two for as I was working through these services. But if you wanted to create a new one, for instance, you would click import reference genome. And then we would go ahead and in this, give it a name, give it a description. We would give it a an object, a VCF file that we are, sorry, a FASTA file that we are wanting to use for that. I have a URL that I've given you in the doc to use for that. You would create a new service role, and then you would import reference genome from there. So what exactly is this FASTA file that we're using? And you would have it listed here. So a FASTA file is just really a sequence file. So you have, this is an example of a chromosome 1 human genome. And then this is the beginning where they couldn't sequence it, so the ends just mean they couldn't do it. And then after that, you start seeing the actual sequence that's involved. And these are very, very, very long files. So after you create your reference store, then you'll need to create your sequence store to hold your samples. So clicking here to reference store, and then after that, click the create sequence store button. You'd enter a name and a description, and browse for a bucket here. I have a fallback bucket, for instance, there. Or you could create one as well if you wanted to. And then after that, you want to keep these settings. You can turn off logging and then go from there. That will create a sequence store. And then this is my sequence store that I had. Now, once you've created your sequence store, you want to be able to put your samples in your sequence store. So what we're going to do is I'm going to select it, go inside of, oh, there it was back there. I do apologize. Just select it and then import files to create resets. And then using, you want to create a new service role here. And then at this point, you want to give it a location of where your actual files are. I've given this to you as well in the document. And this is actually in the manifest file I'm going to upload in a moment, but this is needed still. Click that there. We're going to choose a manifest file here. I will show you what it's inside in just a second. And then, so here in the manifest file, it's really just the names of the subjects, the samples, and then URI to the actual files themselves, the FASTQ files. And then after that, you'll import the data into it. And you'll select your reference you just made, and then you import it in. Now, what is the FASTQ file? So once again, what you saw before, the FASTQ file is just a sample name for the most part, and then it is paired FASTQ files, which is how the sequencers do it. They give you data in pairs, reading from one way of the DNA or the other way from the DNA. It sort of attacks it from both sides. All right, so now we've created our sequence store as well. So we can see here, that's this one here. And then after that, we're going to go ahead and move over to running workflows. And so here, ready to run workflows are workflows that already are pre-installed into AWS, right? And so with that, we're going to pick the GATK best practices genome that takes FASTQ files, like I mentioned, and turns them into VCF files. And so that's the one we want to run. So we're going to select that. We're going to create run. We're going to give it a name. We need to select a S3 bucket where the outputs will be placed. And then you want to use the role that we created at the very beginning, the Omics Unified job role. And then after that, click Next. Now we're going to have to give it a parameters file. And so we're going to upload that. And I'll show you what it looks like inside of it once I get this uploaded as well. Okay. Now, what's inside of that parameters file that we just did? Here is the parameters file really is just looking at just specifying the input FASTQ files that it's going to be working on for the most part. So now after that, we've got everything uploaded that we're going to need to run. We click Next, and then it lets you review things, and then you would hit Start Run. I'm not going to do that. This one takes about 2 hours to run. I've already done that, and so you got outputs from it. But feel free to run it if you'd like. And so after that, then you'll have your VCF file. So what's a VCF file? So VCF files are when pipelines are used to find mutations of sorts. They have a little bit of a header here, which just gives some information about the how they were ran. But the more important thing is down here, the different mutations, variants that it found. And so in chromosome 1, in this position, it found this mutation. This is what it should have been. This is what it was found to be. And then some information about sometimes quality or other kinds of information around it. But the big pieces are here, and for the VCF files on knowing where mutations or variants are. So that's one of the file formats that's used for variants. And so the output has been now made from the workflow. And now we need to go ahead and start making a variant store with those outputs. And so we click on variant store. So to create a variant store, we would click create, give it a name, give it a description, select the reference, and then just create it here. So it's a pretty quick way of creating the store itself. Now, once you've created the store, you need to import your VCF file that you've made from your pipeline. So we're going to go back to that. Click here. We select the variant store. We import variant data. And then for this one, when you're just importing the data, you can just use a new service role. That's okay. You want to select the file of interest. In this case here, I'm going to go ahead and I've given you a file that you can use, and so I'm just going to go ahead and paste that here. And then you would create an import job. And what that does is it imports the variants into the variant store for you. And then you have that. And an example of that is this. Then you need to go ahead and get your ClinVar data in, or your annotation store in. So here I clicked on the annotation store. I've got a couple made already, but what you would want to do is create your annotation store, give it a name, give it a description, say it's a VCF file because that's the format you're using. Select the reference that you made earlier, and then create your annotation store. And once you've created your annotation store, once you've created your annotation store, you need to, as well for this one, import your annotations into the store. Once you've done that, you can't do it. So I had to make a new one for that purpose. So if you click here and we look into it, it allows you, because it's empty, it allows you to click import VCF file. Otherwise, it will just show you the information around what you've imported already. And so we're going to select that. And then for the for this here, you can just create and use a new one. Once again, you would select your VCF file here, and then everything else is fine. And you would click Create Import Job. And so then you have an annotation store, and it's got your annotation file in it as well. All right. So with that, now what we have is in the health omics space, what we have is we had reference store and sequence store. This were our reference stores, our human genome. Sequence store was our samples. Variant stores were outputs from analyzing the samples. Annotations are the ClinVar annotations we're using to see if mutations have some kind of clinical relevance. And both of the variant store and the annotation store have their VCFs loaded into them. And so those are ready to go. So at that point, you'll want to start using Athena to be able to analyze the data. But you have to get Athena to be able to see these data stores. And so to do that, you have to go to AWS Lake Formation. And so in AWS Lake Formation, now if you haven't used the AWS Lake Formation, when you first come to it, there'll be a pop-up and it will say, like when you click your Get Started, it'll be a pop-up and it'll ask you to, if you'd like to add an initial administrative role, and it'll have highlighted myself. Just do that so that you can move forward, and that will have you as an administrator to work on in the space. But you have to add that when you first used AWS Lake. So that's what's happening. But what we're needing to do in AWS Lake is we're needing to, for both the variant and for the annotation database, we're needing to create a resource link so that we can use them in Athena. And so here on the left, we have different databases. And of those databases, for instance, we have a variant database. And you can go here, you can create a resource link, name that resource link, and then click Create. Then you can go back as well to your databases, go to an annotation, your annotation database, create your resource link, name it as well, and click Create. And that's going to enable you to be able to use the Athena console to query. And so now that that is done, now we're going to move over to Athena. So Athena is where we're going to be able to do a lot of the different querying from the resources that we've created from those pipelines. So first things first, whenever we're going into Athena, there's a couple settings you might want to consider doing. So the first thing, so if you're not here, when you get to Athena, just go here and click on Query Editor. Settings and Manage. Here you can set your bucket if you haven't set your bucket already. So just keep that in mind and then you can hit Save. But that's the most important thing there. And then as well, if you want to make a work group, you can go here. I've made a couple, but if you want to create a work group, you can click on Create Work Group here. Give it a name, a description, use Athena SQL. I have this on manual, it's up to you. Select Athena 3 if you do manual for this, and then create work group. I've done that already. And what that does is for Athena, that it ends up allowing you when you're in the editor itself to be able to work between work groups, move between work groups. So this is the primary work group that I had when we were in class working with Athena, and this is my project. So now we're in Athena. So we're able to finally query the data after generating it. And over on here on the left, we have a couple databases. You can ignore the middle one. The first one is my annotation database that I have that resource link for. And the second one's the variant database. And inside of each one of these, you can see there's a table here for annotations, and then there's a table here for variants, right? And they're similar because they were both derived from VCF schemas. So in thinking about different queries here, the first thing I did starting off is I just selected all from variant DB final project dot variant store final project limit 10. And what this is doing is it's saying look into the database, the variant database, and select all from table. And so I'm using these fully qualified names where I have the database name dot the table itself or whatever I'm using. And that's allowing me actually to query both databases at the same time in the same screen here, because otherwise you need to move between them to be able to work with the tables if they're not fully qualified. And so when I hit that, then my results were here. And this is some of the, like you saw earlier when I was showing the VCF files, these are some of the information you would expect, like what chromosome, what's the reference, what did I actually get, what's the quality. You saw these before in the VCF format. So that's for the sample variants. For the annotations or the ClinVar references, those were also in VCF schema, so you would expect to see the very same type of information. These are known mutations that have different clinical relevance, and some here metadata about the significance, the level of significance. And we'll use that in a moment. And that's once again just querying the first 10 so you can see the data. Now here is a query I was just doing to warm up. And so this one here is selecting all the chromosomes and counting how many mutations are in each one. And so that's what we see here. And we see that at the top, chromosome 22 is there. It's got the least. And the bottom, chromosome 1 and 2 are there. And that kind of makes sense because the chromosomes go from big to little anyway. So the chromosome 1 and 2 had more space to collect mutations anyway. So this is a fun little thing to see, but it's not very useful as far as analysis goes. However, this one is. And so this is a query that we have. I'm going to make this a little bigger for us. And what this query is doing is I'm going to show you that it runs. Okay, so we'll let that go as I'm talking. So what this is doing is it's first saying, okay, I'm going to grab some information, show me some information from different samples, the sample file that I had, and we're going to look in that sample file, right? And we're going to join that with the annotations. And I want the annotations that are in the same location as the variants, the mutations I found are, that were considered to be likely pathogenic. So this is giving us the results of the samples that are known to be likely pathogenic given ClinVar annotations. And so for this demo data, we have 9 different chromosomes that come up that are found in the samples that are mutations and that are considered likely pathogenic. And so that brings us back to my presentation to sort of finish up. So what I was able to show you was we started off and we created the sequence stores and the reference stores for the human reference. I showed you how to start up a workflow and you could run to create a VCF file. We used S3 for a couple things. VCF files as well. The Athena, when you set up the settings for Athena, your logs can be stored, your queries can be stored in their S3 bucket that you set up in the settings. But it's certainly S3 is being used for some of these files. And then we create a variant store and an annotation store. Variant store with the VCF you can use the VCFs from the outputs of the pipelines to create the variant store. And here the ClinVar, for instance, reference was used to create that. And then those can dual be, after resource linking them, they can be queried in Athena and then could be jointly queried together if you use their fully qualified names. Thank you so much for your time.